For something almost completely different, I'll talk about window management. We call it user. It's really kind of a great name. It started from user interface. User does window management, user interface such as menus, dialogues. Is everyone familiar with what a dialogue is? Dialogue is a little window that will come up. It's kind of a transitory window where you can input information into. All the little controls, we call these things inside of dialogues controls. There are supported types of windows that user supports. They're like button controls that say OK and cancel, and scrolling lists of items, and a couple of other kind of input fields. And it also user also was responsible for raw input, like keyboard and mouse processing, routing that to applications, and all messaging between applications. Most of user is primarily callback based. A lot of windowing systems are callback based, in that when the windowing system wants some event to occur, or wants to notify the application of some event that has occurred, it'll call back the application and tell it that event has occurred. And probably about 40% of the API for users is represented in terms of these callbacks, which we call window messages. Our primary goal, as with the rest of Windows, of Win32, was to make the APIs as simple a port from Win16 as possible. That was our first goal. And so where possible, we've tried to widen to 32 bits and make the porting process for ISVs as small as we can. The other big change, of course, was support for multiple preemptive threads of execution. Any thread inside of a Windows process, Win32 process, can create windows, do input processing, etc. We have an improved input model. What this means is an improvement from Win16-bit Windows, which was a non-preemptive system. All input from device drivers went into a central queue, and applications took turns reading this input out of the queue. So if one of the applications that was reading input decided to go off and hang, or read the disk, or do some network activity, or something that took a while, all the other systems would hang because they couldn't get input. So we've turned this into a model where a user can now interact and input into any application, no matter what the state is of any other application. The other thing one major change that we're adding is there's a lot of improvement in NLS support. NLS stands for Natural Language Support, and that's for our international customers, so that to try and make it easier for ISVs to create international versions of applications. Our goal for Win32 was to create a system where an ISV can make one binary, and by changing resources and other national or language-specific things can ship additional versions. One of the major differences here is something we call Unicode. You've probably heard about this Unicode conference. It's a 16-bit character set. Every character is 16 bits, and it supports all the characters of the world. We also remained ANSI compatible, and what we mean by ANSI is kind of a word that we use to mean the Windows 3 character sets. Windows 3 was an 8-bit character set, so there's 256 characters per character set, unless you go to Japan, in which case some of the characters were 1 byte, some of the characters were 2 byte, and everywhere you went, wherever you had a major difference in character set, just use a new character set. So that's what we call ANSI. So we are remaining compatible with ANSI for 32-bit applications, because it's a significant porting effort to go from an 8-bit character set to a 16-bit character set, pervasive through your code. We're adding security. Dave probably already talked about security goals. Again, the security parameters are ignored on JAWS and are supported on JAWS. user isn't really like a subroutine library where you make a function call with a known set of parameters and you get a known set of return values back. It's a little more complex than that, and then you make a function call and you can be called back with window messages 5 times before your function returns. And what window message you get called back with can be completely dependent on what the state of your application is. And that's kind of complex for ISVs to code to and to test to. And it's very important to be compatible with that, with message order. When we make a function call, an application has tested itself to be compatible with a certain message order back in the system, a window message order. And we absolutely need to retain that. So we're very compatible with Win16. Handles used to be 16 bits, become 32 bits. We have a couple places in the API where we are storing handles in 16-bit quantities. Window messages are comprised of a couple of fields under Windows 16. These fields are 16 bits, and so window messages now need to change a little bit, where we have this handle expansion problem. We need to fit them into the message parameters of window messages, and that affects 18 window messages out of a lot, probably about 150 window messages. The other place where we had size dependencies, we had a couple APIs where we actually set handles into things we call words, and words are 16 bits. And these people who use these need to change as well. H instances are replaced by H module. That's something that is not too important. Multiple threads. As I said before, any thread can create window, do window management. When a thread creates a window, any window messages or input it gets for that window are only sent to that thread, the creator thread.
Can you pass ownership to another thread or another process?
No. You'd have to communicate the fact that you want to pass ownership and have the other guy create a window with the same attributes, so it'd just be a recreation. You can't pass ownership of an existing window to another thread or application. Windows created by that thread receive messages in that thread. Each thread has an automatic window message queue. When you get input from the system, keyboard and mouse device drivers, that queues up. And the queue is an automatic thing that the threads don't need to create explicitly, and it dynamically sizes.
Are there problems with overflow?
Yeah, there always is. We have to do things like, for example, we have to make sure that once we have a definite size, we're not going to dynamically size it forever. We have to make sure that if we get a down event, like mouse down or keyboard down, there's enough room for the up, so that you don't get into conditions where the system thinks keys are down or the mouse is down. We've had those problems for quite a long time.
Can you?
Yeah.
Go
ahead.
When the server side, what do you do about arranging priority of handling messages from different processes? How are they interviewed?
The application processing input gets a higher priority, and that measuring that priority against other threads and handlers in the system is always kind of a fine-tuning process. I have not done that yet. So that's going to be, in the past operating systems we've done essentially the same thing, and that is the application that the user is concentrated on, the user is interacting with, or the thread that the user is interacting with gets a higher priority than the rest of the Win32 application could. Win16 applications could hang the system by not processing input. This was a major thing. It wasn't so bad of a problem on a non-preemptive system where if you didn't call yield, you'd hang the system anyway. On a preemptive system, this certainly isn't, or on a system that you want to be robust, it's clearly something you want to fix. What we're doing about it is allowing the user to switch to any application, no matter if that application is processing input or not, and input into that application, no matter what the application is doing. And finally, for hung applications, an application that isn't processing input by our considerations, doing either hung or doing something that's taken quite a long time, the user can still interact with it in a limited way. And that is, he can minimize it so it reverts down to an icon form, or he can close the application, or he can move it out of the way. Those are the sort of things you can do to a hung application. On Win16, there wasn't a common unified method or strategy for returning error status. We tried to do a better job of that on Win32. All available APIs return error status. Like Mark said, if someone passes in a bad pointer that is bad, points to invalid memory, it will raise an exception.
Hang on, will it return an error status or will it raise an exception?
So there's no way basically to arrange for one process that has one window to gather up button clicks that are outside of itself.
Yeah, you can do that. And that's called capture, mouse capture.
Right, but when you move outside of a window, I think if what I understand is correct, if you move outside of the window and your mouse is up, you're not going to get it.
Correct.
Right.
That's correct.
So you can't arrange to trigger something and then go somewhere else and click somewhere else and get that event back.
Right. That's a byproduct of changing to this different input model. Now, when we go down in the window, if the application happens to capture the mouse, then we're going to keep all the inputs in.
That's the easy case.
Yeah. Yeah. IO errors and application exceptions are reported through GUI error dialogues. If you're familiar with those two, it would flash to a character mode screen and bring up a register dump. And we're going to fix that. Win32 is robust, designed not to crash. So if we do have if the system does go down, if one application can affect another application, it's a bug in the system. The stability of another application is a bug in the system. We'll fix that. Here's some of the things we're doing with international support. First off, language IDs can be specified for constructs in the system which automatically sort, or which do sort. For example, we have things we call dialog box controls I was talking about earlier. One's called a list box, which contains a list of strings you can scroll through. And applications can just set this flag that says sort these things. And that's completely dependent on language and so in applications, the big model we're moving from is under Windows 3. There is one language and associated international settings for the whole system. And now applications can control their language settings independently, so they can display multilingual text, sort multilingual text according to the customs of that text, etc. Keyboard layouts can be switched with hotkeys. This is a request from some international users that they might want to switch between a keyboard and a French layout very easily. And we allow that with a hotkey. Keyboard layouts are customizable, so you can create your own keyboard layout. And we have support for input method editors, which are DLLs, which hook into the input stream for an application that allow, for example, Japanese users to input a phonetic representations of kanji characters, and then this translator will go find the kanji character and stick it in the input stream.
How do you see the state of it while you're editing it?
It's a little status bar, and it's
At the bottom of the screen or at the window?
well, that's a good question. In past systems, we've done both, and right now we're planning for it to be up on the screen. Okay. Another feature that we're adding is bit caching for Windows, automatic bit caching. Applications like CAD applications or applications that do really complex drawing take quite a while to draw. So you want those things to draw into a bitmap so that when the system asks the application to refresh that, it's an instant thing. So also allow you to start something drawing, put it in the background, and go do something else until the thing is finished. We've enhanced it a little bit, so when the application's on top of all other windows, it actually draws to the screen, so we don't go to this bitmap and into the screen. Another thing that we're adding, some customers have asked us for this over the years, is the ability to output both user interface and graphics calls to a different monitor. Applications, some uses of the system include 2 monitors or a dedicated monitor for something like someone doing CAD. You have this nice high-res monitor, and then you have your work monitor, and this will allow people to do that. As well, it will allow applications to take advantage of a given display hardware. If it can display multiple modes, the application can take advantage of that. That's it. Any questions?
Let's see. Because you're doing Unicode, how are you going to do your code to glyph mapping?
Chuck,
Yeah.
talk about that.
Kind of an interesting question. Right now we're looking at a nice tree structure that allows you to look at, say, the first 8 bits, okay, and you have 256 possible byte entries in a table. And they, of course, can be empty. And then if you have a hit in that table, then you go down to another 4-bit type table. And that, again, will take you to another level where finally you'll have these blocks of 16 32-bit handles that are your glyph IDs for whoever is supporting this thing. Could be a font driver or device or something.
And what do you do about things like tildes and stuff like that?
Tildes and stuff like that, well, they tend to be either characters by themselves or they can be composites. So,
Right, I guess what I'm asking is, so you're going to have composite support?
yes.
Absolutely.
Good question right now. There's some screens that support the ability to have one window of a particular depth.
Well, it really means what you're talking about hardware support for Z ordering, right? I mean, we can order an application.
It's sort of a different issue. I mean, you know, given that you've got Windows, given that you're going to do essentially backing store, you're going to keep track even when it's not on the screen. That can be fairly expensive if you're storing it at a depth more than what is needed.
Oh, I
So,
right. You mean color resolution? Like the guy only uses 4 colors. Hadn't planned that, but it's a good point.
Okay. Now let's see. You're going to put most stuff over. You're going to put both the GDI calls and the user calls over. The GDI, the user stuff, over in a separate server.
Most of it.
Okay. What kind of performance do you think it's going to take for doing that?
Well, we did a lot of work on that early, and we still have more work to do. What we're looking at, Chuck can talk more about it, is particularly for DDI, caching attributes on the client side until we really need to call the server. Like, you know, you set some attribute, you don't really need that attribute, so you do an output call. And we're thinking about batching those calls up so that We only cause a server call when it's absolutely necessary. When we need to when we need to return some object, for example, an object handle, we might need to call the server.
Have you guys looked at supporting both X and Windows simultaneously?
I've looked a lot about issues concerning that. For example, supporting Windows and PM and kind of primitives we'd have to share between them. We did something called Porthole, where we wrote Windows on top of PM, and all the issues regarding that we can talk freely about. I guess tomorrow we have a meeting at 9 a.m. and we can get into that in depth.